Okay, so today I will do the openness in of chapter 9. So 9.1 will some recall some uh, definition and state the main result, and 9.2 we prove some semi-algebraic properties of the some character varieties, and 9.3, we will introduce some way to compactify the orbifold and relate these to local homeomorphism properties. And so 9.4, we prove the main result, uh, showing the openness of deformation space in the character space. And 9.5, we will do something, some identification with my old definition of the deformation spaces. Okay, so the deformation space and the space of holonomy representation homeomorphism. So we'll have all the ends will be R or T type. So T type is always radial, but the I mean R type is always radial. The T type is either totally geodesic or is horospherical. So let's say E1 to E to the E1 is the Rn, and then E to E1 plus 1 to E1 plus E2 is the uh, Tn. And so we will always give some compact orbifold with smooth boundary whose interior is also so actually there might be more than one compactation, but we will fix one of these O bar when we give O, then we will have this O bar. So the radial foliation we recall is just for the radial or horospherical end is a radial line. So the parameterization by sigma A times 0, 1. So this goes to a radial line for each of that, and then as t goes to 1, we escape to the n. And for the Tn, you given a neighborhood defined to 0, 1, where S is the ideal boundary component. So we can identify U with S E times 0, 1. So by the identity, and so of the isotopy, this identified with the ideal boundary as this compactified one O bar corresponding to E. So this is a compatibility condition of O bar with totally geodesic end structure. And for Rn's 나 참 거기는 리코딩 하고 있죠. 예. For Rn, we require that the vector field tangent to the ellipse extends to the smooth vector field transverse to the corresponding ideal boundary. Here, and OVA. So Rn, you still have OVA, and the point is that so this ideal boundary, so this leaves the smooth vector field will extend to the boundary component. Okay, so when you extend this over by small bound, so you still have some geodesic, I mean the flow going, I mean the tangent vector field going there. Okay, and then going to transverse one, and then so Tn, the identification U extend to the closure of U bar as this. Okay, so so we always assume that O bar is a very good orbifold, since we can identify O bar with some or remove with some union or open neighborhood of the product form as above. So we can always so O itself has a very good orbifold because it has a projective structure. So O bar is a very good orbifold. Okay, and so of course there's also isomorphism of the fundamental group. So we can always identify this O tilde with. So you take the universal cover of O bar, and so there is an embedding of the universal cover of O to O bar O hat as an inclusion map, and then we can identify tilde as a dense subset. Also, the isotopy is a self-diffeomorphism, so that there's a smooth orbifold map, so that IT is O to O given by IT JXT, and where I1 is I0 is the identity, and I is the I1. Right. So of course we need the fact that this is a smooth orbifold map, and we require IT to be the restriction of the isotopies. Okay, so this is uh, these of course isotope has to extend to the OBA as well. So because of all these conditions, so this is a requirement. Thing to say. So we define depth E or to be deformation space of your projective structure with N structure. So this is a quotient space of your projective structure on satisfying the above conditions for which type of RNT type RNT under the isotopy human relation. So so the so uh, okay, so anyway, so I think this is repeated. Sorry about this. Right? Okay, so for XG structure on another orbifold deep homomorphism induces XG structure pullback from all head O prime with the given by using the preimage in the local model of all head. And so also if there's an isotopy, we can lift this to O tilde so that the F this isotopy at 0 is the identity, F T is F1 T is 1 I so that this lift also has at 0 is the identity and F tilde 1 is the lift of I tilde. So I mean lift of iota. Sorry, this should be 1 here. So we call this I tilde the isotopy lift. Okay. So if you consider just a compact crossover fold, then we can define the isotopy equivalence relation as a space of developing pairs quotient by the isotopy lift of the universal cover, and the deformation space is given as this quotient of this by the action of G. Okay, so this G will act on the right. Okay, so like this depth circle, right, G circle. I mean on the left, sorry, and this H by the conjugation. So essentially, that will determine H. So it is just left action, and of course the so here the quotient here is the right action because you can always compose this that by the multiplying on the right. Okay, so by this isotopy. Yeah, okay, so these are all so we can give a compact open CR topology using the on O tilde. Okay, so that will be the topology of the compact case. So the now we want to do the this character variety thing. So we do the semi-algebraic properties and related topics. So O is a strongly tame, and the fundamental group is finitely generated, and let's say G1 to GMB generators. Okay, and of course it's finally presented as well. So we can give you a home pi 1 G for Lie group has an algebraic topology as a subspace of GM. So because each generator is you can put it into G sub M, okay, because this is the number of generators. So you can for each element you can put it here. So this is a subset of this, and this the topology is given by algebraic convergence. So HI goes to H if this is converges for each generator. Okay, so and then the conjugacy class of representation is called the character here, and so the character variety is rep space or rep variety is said to be rep pi 1 O P0 n plus 1 R is the quotient of this by the conjugation action. Also, you can also do it for the SL n plus 1 R, and so this is not a variety in the sense of algebraic geometry. Okay. So the representation is stable if the orbit of its representative is closed and stabilizer is finite on the conjugation action. So in this set and then the representation is stable if it's irreducible and no parabolic subgroup contains the image of rho. And the stability and the irreducibility is open condition in the Zariski closure. Okay. So these are also, I mean, these are only true in these groups here, so don't think otherwise. And the stability and irreducibility are open conditions also. So these are all from this Johnson and Wilson paper, and if rho is Zariski dense, then of course rho is stable, and because it's not contained in proper parabolic subgroup, and the PGL n plus 1 are X properly on the open sub stable representation here. Similarly, SL n plus 1 X stably on here. So the representation of a group into this is strongly irreducible if the image of every finite index subgroup is irreducible. So actually many orbifolds has strong irreducible and stable representation. And eigen one form is a linear transformation of a linear transformation. Gamma is a linear functional in Ln plus 1, so that these alpha circle gamma is lambda alpha for some r here. Okay, so if you look at this home E, so we define home E of pi1 or PGL and R. So this is a subspace of representation satisfying the vertex condition. So if you have a R-type N, then then this has a non-zero common eigenvector, positive eigenvalue for the lift here. Okay, and the lens condition is that so pi1 X on a hyperspace P for a T-type and fundamental group, and X discontinuously compacting on a lens. So L is a properly convex domain with this L intersect P is actually L intersect P and it's not empty. Or this is or it acts on the horrible tangent to P. Okay, so that's the lens condition. So it either acts on lens or it acts on the horrible. So we denote by the home S of this to be stable and irreducible representation, and this home SE to be the intersection with S, and so home EU will be the subspace of representation H, where H prime E has a unique common eigenspace of dimension 1 with positive eigenvalues for the lift, for the R-type ends, and also, I further require that so there should be some finite many elements in the fundamental group, so that the intersection of the cyclic space of lambda I associated with above common eigenspace. If you take the intersection, this is still one dimensional. Okay. So this is for the stability openness condition, and P for the Tn we have a pi. E has a common null space of eigenspace satisfying the following. So pi1 EX properly and co-compacting on lens with L intersect P equal to L0 intersect P with the Hausdorff quotient, or it acts on some horosphere tangent to P. And it's unique, such one for each P fundamental group for P-ends of type, and of course, dual group, so you take the dual, then it has to satisfy this star, okay. So this is for the symmetry of the situation, but so for Tn's lens condition is satisfied hyperplane, and P and P is unique one, satisfying the condition in other words. And so this home S of EU of this group is just intersection with home S of this. Okay. Okay, so the above condition T satisfies some principal boundary condition for the real projective surface. So in the surface case, there's some sort of a So for each principal geodesic boundary, there's some again there's some sort of lens or convex neighborhood there. Okay, so if his parent is finite general and there is only finitely many conjugacy close of pi 1 of E. Okay, so then anyway, so this is a closed semi-algebraic set. And we can define this EF of pi 1 of PGL plus 1 so that this fixes only finitely many points. Okay, and so this condition is that this is an open condition by lemma 9.22. Okay, so lemma 9.22 is that if you have a semi-algebraic subset of PGL and plus an M, and there is so for each element in B, and there is a function where E is the space sub dimension of W, where W is a subspace fixed points of each GI, and where we define the dimension of empty set to be -1. Then the B goes to this dimension is a upper semi-continuous function. So the maximal dimension is upper semi-continuous function. Okay, so the reason is of course that if you have any such a subspace, in the limit the dimension will always so the fixed point set limit will always have a bigger dimension. So that means it's going up. So that means it's upper semi-continuous. Okay, so that's so this is that if you restrict it to 0 dimension, then it is an open condition. Okay, so the lowest dimension, then this space is open. And the proposition 9.23 is that this is an open and open subset of semi-algebraic set here, and so is this one. Okay, so the basic proof is this is so we have some thing in the open set here of this open subset of this, and then you consider these cyclic spaces, and they meet in intersection of 0 dimension and then so that's there's some transversality among here. So that means that as long as you're very close, you still have some transversality. So you get only 0 dimension, keep getting the uniqueness, okay, of the open condition here. Okay, so and then for the T end, we have a similar argument. Okay, so I will skip that. Yeah. And so we define this rep E to be this one quotient by the quotient space. So this may not be Hausdorff, and we define this to be subspace like this, and so we quotient these, and then you obtain these kind of spaces, and these are all Hausdorff, and they are semi-algebraic. I mean, it's open subset of semi-algebraic set if you do these kind of thing. And then next you want to look at home E of parabolic pair of this. So this is subspace representing going to cusp group, so parabolic subgroup. So this is a closed semi-algebraic set, and the G is a finitely presented group. So this is going to be closed subset, closed algebraic set. So the reason is that if you have PB, so let E be an N orbifold, and then E is a home E, and you define this home E RL to be the space of representation where this acts on the lens cone, and the P is not in the lens and acts properly and co-compacting on lens itself, and is assumed to be the bounded subset of some affine patch. So so it is a open subset of a semi-algebraic set in here by the option 5.3.11. Okay, so by the stability, there's openness condition there for this lens condition. Okay, and then for TL, you have it acts on lens, and so it is acting. So again, there's a stability condition. So this is again open subset of a semi-algebraic set. Again, and so if you restrict this home to pi1 of E to pi1 of E, then the restriction map correspond to N, and so the representative set, you take the representative set of each N, and then you define these home LE to be the inverse image of this restriction under this restriction for each N of this parabolic plus this, and then parabolic plus TL. Okay, so then those will be, so this will be the space that we'll be working with, and the portion will be denoted by this. Okay. And so this is the stable part of those, and the X is this. So the portion space under this is, so for you can also define these, and then you can also do so these will all be semi open subset of semi-algebraic set here. Okay, so that's the first half of the lecture. So I'm back at 5 minutes later.